Hi, here we go with another graphing rational functions video. This time, however, we're in polynomial form. So we have f of x is equal to x minus 1 divided by x squared plus 6x plus 8. Again, the first step we do is find the vertical asymptotes. Again, we set the denominator equal to 0. In this case, we can see that the function or the polynomial x squared plus 6x plus 8 can be factored into x plus 2 and x plus 4. I set each of those equal to 0, and we get vertical asymptotes at -2 and -4. So I went ahead and graphed those for us now. Vertical asymptote here at -4 and at -2, the vertical lines, those vertical asymptotes. Now, the second step is we want to find the horizontal asymptote. So, if I want to find the horizontal asymptote, in this case, we're not dealing with the vertex form. We are dealing with the polynomial format. So we have we base the three different rules on the set of y equals a to some to x to some nth power divided by b times x to some mth power. So the rules are if n is greater than m, again, there's no horizontal asymptote. We could actually divide the denominator into the numerator, and what we'd end up getting is a slant asymptote as long as the power of n is greater by 1. If n is equal to m, then the horizontal asymptote is found by y equals the ratio of a over b, which are the leading coefficients of the polynomials. Or the third rule is if n is less than m, then the horizontal asymptote would be at y equals 0. In this particular case, we look and we notice that the power of the numerator is 1, the power of the denominator is 2, so we have a case where y is equal to 0 because n is less than m. Alright, so what we did was we went ahead and graphed the horizontal asymptote. We make sure we label it so we know what we're doing, and now it's time to plot some points. So I can build a regular XY chart here and start finding some points to either the right or the left of the vertical asymptote. And in this case, we've got a middle section, so we also have to deal with that. So if I choose a point to the right, I plot 0. And I urge you at this time to go ahead and pause the video, see if you can put the zeros into the function and find out what you get. And when you put a 0 into the function, you get -1/8. So at 0, I'm at -1/8, which is there. And again, for most of these, they're going to have a similar pattern to them. They will often go from -infinity, come through the point, and then go to -infinity in the y direction. And that's what this one does. So they'll hug these asymptotes, and so you don't need more than a point or two to determine what it looks like. If we wanted to be very specific, we could, but right now we're looking at the general idea of what do they do in general. All right, so now I've got to go to the middle section, see what it's doing. It could be in the top portion or the bottom portion. So I plot -3. Again, urge you to go ahead and put those values in and see what you get as a y value. All right, now that you've done that, you should get a -4 or a +4. And so what we see is that at -3, we get a +4. So this time it is there, and going off to +infinity in the y direction. And now we have one last place, so I'm going to choose -5. And again, pause the video, see if you can figure out where -5, an x value of -5, and what the y value would be. And once you do that, you will get a negative 2. And so at negative 5, negative 2, there's a point there. And again, you will see a graph that looks like that. Okay? So we've plotted our points. We have our basic graph. Everything is labeled that we need so we can understand what the graph is doing at each point along the way. Anyway, stop it, rewind it, go back through it a couple times, and make sure you know how to do this. All right? Thanks again. Have a great day.